Topic 1.5, Integrals involving powers of trigonometric functions. Some trigonometric integrals may be integrated by transforming the integrand with the use of familiar trigonometric identities such as 1. Cosine squared theta plus sine squared theta is equal to 1. 2. Tangent squared theta plus 1 is equal to secant squared theta. 3. Cotangent squared theta plus 1 is equal to cosecant squared theta. 4. Sine squared theta is equal to 1/2 times the quantity 1 minus cosine 2 theta. 5. Cosine squared theta is equal to 1/2 times 1 plus cosine 2 theta. And 6. Sine theta cosine theta is equal to 1/2 sine 2 theta. Itong mga identities na to ay familiar na sa atin. The first three identities ay tinatawag nating Pythagorean identities. And 4 and 5, ito yung tinatawag nating power-reducing identities. And 6, ito yung tinatawag nating double angle identity. Okay. Yung formula 1, 2, 3, ito ay na-discuss ko na sa previous na lecture natin. So, in order for us to get formula 2 and 3 or identity 2 and 3, so yung gagawin lang natin, we have to divide the formula number 1 with cosine squared theta or sine squared of theta. So kung i-review natin from our formula number 1, so we have here the cosine squared theta plus sine squared theta is equal to 1. If we are going to divide everything by cosine squared theta, so we have here cosine squared theta divide cosine squared theta, and we have here 1 plus sine squared theta divide cosine squared theta is tangent squared theta, and 1 divide cosine squared theta, and we have secant squared theta. So that would give you your formula number 2. Then, if we are going to divide everything by sine squared theta, then we have cosine squared theta divide sine squared theta is cotangent squared theta. Sine squared theta divide sine squared theta is equal to 1. And 1 divides sine squared theta is cosecant squared theta. And this is your formula number 3. So, saan naman ang galing itong power-reducing identities natin? So, we have the sine squared theta is equal to 1/2, 1 minus cosine 2 theta, and cosine squared theta is 1/2, 1 plus cosine 2 theta. Ang papalabasin nating formula dito is sine squared theta is equal to 1/2, 1 minus cosine 2 theta, and cosine squared theta is equal to 1/2, 1 plus cosine 2 theta. So, saan ang galing tong mga to? If we are going to remember the sum and difference identities, so from the sum and difference identities, kung hindi pa natin memorize to, so kailangan din natin siyang i-memorize. Pero ako, ang ginagawa ko, ganito yung ginagawa ko para hindi ko siya makalimutan. I have here sine of angle A plus angle B. We have sine of angle A minus angle B, and cosine angle A plus angle B, cosine of angle A minus angle B. So, ang ginagawa ko dito ay gumagamit ako ng code. So, for the sine, I have, so sin, that would be sin, palaging AB yan. ang pagkakasunod-sunod. So, pag sin, I have the sin, cos, cosine. So, sin, cos, cosine. And so, sin, so that's again, sin, cos, cosine. And for the cosine, so cos, I have the cos, cos, sin, sin. So, cos, cos, sin, sin. And cosine again, so cos, cos, sin, sin. Now, kay sine, kung ano yung sign na nandito, gagayahin lang natin. So, we have here plus and minus. For the cosine, we take the opposite, no? So, if this is plus, so dito ay minus. If this is minus, this is plus. So, yun lang yung tinatandaan ko para hindi ko makalimutan itong mga formulas na to. So, for the sine, I had the sin, cos, cosine. So, same sign. And for the cosine, cos, cos, sin, sin. So, if we are going to simplify this para hindi natin siya, para isulat natin siya ng mas mabilisan. So, pwede natin siyang isulat ng ganitong way. So, I have the sine A plus and minus B. And I have here cosine A plus and minus B. So, for the sine, as I have said, sine is sin, cos, cosine. So, sin, cos, cosine. And I just copy the sign. So, that's plus and minus. And for the cosine, I have the cos, cos, sin, sin. So, I have cos, cos, sin, sin. Now, I have to take the opposite. So, that's negative, positive. So, ano ibig sabihin nun? If that is plus, so this would be also plus. If this is minus, this would also be minus. While for the cosine, if this is plus, this would be minus. And if this is minus, this would be plus. So, mas nakatipid ka ng ink dito. At, of course, same lang naman siya dito. Now, paano lalabas itong formula number 4 and formula number 5 natin? So, i-derive ko siya. Now, galing dito sa pangalanan ko na lang tong A, B, C, and this is D. So, galing dito sa formula na to, sa C. That is cosine of A plus B is equal to cos, cos, sin, sin. So, that's cos, cos, opposite sign, sin, sin. So, if I am going to let the angle A is equal to angle B, then I would say that this is cosine of A plus A, cosine A, minus sine A, sine A. So, lahat ng B ay na-replace na natin siya ng A. So, this would be cosine 2A. And this one would be cosine times cosine. So, we have here cosine squared A. And this is sine times sine. So, I have here sine squared A. Now, if we are going to review our Pythagorean identity, so that's formula number 1. Okay, so dito gagamitin ko yung angle A kasi angle A yung gamit natin. So, we have here sine squared of A plus cosine squared of A is equal to 1. Now, if I am going to express this in terms of cosine, then I would have cosine squared A is equal to 1 minus sine squared A. Now, I am going to replace the cosine squared A, this cosine squared A here, with 1 minus sine squared A. So, I would have cosine 2A is equal to 1 minus sine squared A minus sine squared A. Now, simplifying this, so I have here cosine 2a is equal to 1 minus 2 sine squared a. So if I am going to express this in terms of sine squared, so ililipat ko si sine squared sa left side ng equation, then I would have 2 sine squared a is equal to 1. Si cosine 2a ay ililipat ko sa right side, so I would have minus cosine 2a. So in here, I am going to divide everything by 2 para matanggal yung 2 dyan. So I would have sine squared a is equal to 1/2 1 minus cosine 2a, wherein pwede naman natin siyang isulat sa ganitong form. I have sine squared a is equal to 1 minus cosine 2a over 2. Pareho lang naman yon. So yung formula na nakuha natin, or yung identity na nakuha natin, is just your formula number 4, which says that the sine squared of theta, so yung a, papalitan natin ng theta, sine squared of theta is equal to 1/2 1 minus cosine 2 theta. Ngayon, papalabasin naman natin yung identity number 5 o yung formula number 5. So, saan manggagaling si formula number 5? Yung formula number 5 natin ay manggagaling dito. Sa halip na yung cosine squared theta yung papalitan natin, si sine squared naman yung papalitan natin. So from our identity number 1, the Pythagorean identity, so sinasabi dito na yung sine squared a is equal to 1 minus cosine squared a. So we will replace the sine squared a here with 1 minus cosine squared a. So this equation here, so this would become cosine squared a minus this value. So I have 1 minus cosine squared a. So simplifying this, I would have cosine 2a, cosine squared a minus 1 plus cosine squared a. So cosine 2a is equal to cosine plus cosine, so that's 2 cosine squared a minus 1. So I'm going to express this in terms of cosine squared. So I have 2 cosine squared of a. Si 1 ililipat natin sa kabila. And I would have 1 plus cosine 2a. So para matanggal si 2, divide everything by 2. So I have cosine squared a is equal to 1/2 1 plus cosine 2a. This can also be expressed as 1 plus cosine 2a over 2. So, pareho lang to sila. Now, ito na ngayon yung ating formula number 5 o yung identity number 5. And identity number 5, ito yon, no? So, yan yung pinanggalingan ng identity number 5. Cosine squared of a is equal to 1/2 1 plus cosine 2a. So, yung a, pinalitan lang natin ng theta. So, it is just the same. So, kahit anong angle pa yan, no? So, kahit ano pa yung gagamitin natin dito, it could be x here and x there. So, the same lang yan, beta or whatever. So, alam na natin kung saan nanggaling itong power-reducing identities na to, 4 and 5. Now, how about the formula number 6? Itong formula number 6 natin, mas familiar tayo sa ganitong mukha. So, we have sine 2 theta is equal to 2 sine theta cosine theta. So, bakit naging ganyan lang yan? Nag-divide lang siya ng 2 both side, kaya nagkaroon ng 1/2 dito. So, saan nanggaling itong formula number 6? Ang formula number 6 ay nanggaling lang doon sa formula A ng sum and difference identities. So, sinasabi doon that sine of A plus B is equal to sine, so that's in cosine. So, we have sine A cos B plus cosine A sine B. So, we let A is equal to B. So, change natin lahat ng B into A. So, I have here sine A plus A is equal to sine A cosine A plus cosine A sine A. So, this would be sine 2A, and this would be sine A cosine A, and this is sine A cosine A. So, since pareho naman sila, and that would be 2 sine A cosine A. So, dito, napalabas na natin yung ganitong form. Para lumabas ng formula number 6, we have to divide everything by 2. So, we have here sine A cosine A, itong nasa right side, and ito, so that would be 1/2 sine 2A, and that would be your formula number 6. So ngayon, alam na natin kung saan nanggaling itong mga formula na to, and itong 6 na formula na to, yung gagamitin natin sa integration involving powers of trigonometric functions. Okay, so we have here the type 1. Sine of x raised to m cosine x raised to n dx. So this case is where either m or n is a positive odd integer. For definiteness, let n be the positive odd integer. Okay, so we have sine of x raised to m. Aalisin natin, no? So, aalisin natin yung isang cosine, and that would be cosine raised to n minus 1. If this is odd number, so, for say, this is 3, so 3 minus 1, this would be 2. So, ngayon, kung magiging 2 na lang yung exponent niya dito, and we will be using this Pythagorean identity, no? So, ang goal natin ay gagawin natin tong cosine natin na even para magamit natin itong ating Pythagorean identity. Okay, so let's apply. We can see here that we have sine squared x cosine cube x dx. So, dito, we have our m is equal to 2 and your n is equal to 3. Kung makikita natin dito na meron kasing instances na malilito tayo, no? Whether we think which one should be the m and which one should be the n, no? So, ang iniisip ko lang dito para hindi ko siya makalimutan, I have the sine of x cosine x. Saan ko ilalagay si m? Saan ko ilalagay si n? So, ang tinatandaan ko lang dito ay, no, so the same with the grammar in English, na hindi pwede yung sentence na redundant. So, ibig sabihin, kung n na to, hindi na pwede yung n doon. So, meaning, kanya yung m, and of course, nandito kay cosine yung n. So, medyo corny lang yung kwento, pero at least, sana makatulong. No? So, we have here, our n is equal to 3. Kasi yung condition natin for the type 1, either the m or the n is a positive odd integer, no? So, either. So, ngayon, lumalabas dito that your n is equal to 3. So, this is a positive odd integer. Now, what you are going to do is to factor out one cosine from the odd, no? Kasi yung odd natin dito ay si cosine. No? So, we have integral of sine squared x cosine, so that's n minus 1, so your n is 3 minus 1, so that would be squared, multiplied by cosine x dx. No, hindi naman natin binago yung equation natin kasi if we are going to multiply cosine squared by cosine, that would be the cosine cube. Okay, so from here, gagamitan natin siya ng Pythagorean identity. Yung cosine squared na term, from here, papalitan natin siya ng 1 minus sine squared. So, we have here the integral of sine squared x multiplied by 1 minus sine squared x cosine x dx. So, this would give you sine squared x. This is sine squared times 1, but we have to multiply also the cosine x dx here. So, that would be cosine x dx minus sine squared times sine squared, and that would give you the integral of sine to the fourth of x multiplied by cosine x dx. So, ang goal kasi natin dito ay para madala natin siya sa form ng power formula. Kasi if we are going to recall from our previous topic that the integral of v raised to n dv is equal to v raised to n plus 1 over n plus 1 plus c. So if we are going to let our v is equal to sine, so that's sine of x, and your dv is equal to cosine x dx. So, ito yon. If this is your v and cosine x dx is your dv, now, in here, your n is equal to 2. So, dito naman, your n is equal to 4. And the same, this is your v and your dv cosine x dx. So, we can now directly apply the power formula since katabi niya na yung derivative niya. That would be n plus 1 over n plus 1. So, direct na lang natin. Hindi ko na siya ipakita ng katulad ng ginagawa natin sa previous na topic natin. So, that would be sine. So, your n is 2 plus 1. So, that would be sine cube x over 3 minus n plus 1. So, that's sine to the fifth x over 5 plus c, and this is our answer. Sa previous case no na ginawa natin, yung n natin is odd. So what if this time your m is an odd integer? If m is a positive odd integer, so meaning yung exponent ng sine natin is positive odd integer. So what we are going to do is to express that in terms of sine m minus 1 of x sine x cosine raised to n dx. So we factor out sine x from the sine m of x. And we will be using the identity, our Pythagorean identity, sine squared is equal to 1 minus cosine squared x. So, sining papalitan natin? Yung part na to. Kasi kung odd integer siya and we factor out sine x, meaning magiging even na to, and i-express natin to in terms of sine squared raised to its exponent, kung mas higher yung exponent niya and that's even pa din, we will replace the sine squared x by 1 minus cosine squared x. So, let's add example for that. So, we let this as our example 5.1.1. Ito ay dinagdag ko lang and wala naman to sa module ninyo. So, we have sine cube of x cosine square x dx. So, by this time, your m is equal to 3. So, that's the exponent of your sine. And your n is equal to 2, yung exponent ng cosine natin. So, your m is an odd integer. So, therefore, we factor out one sine. And we would have the integral of sine minus 1. So, that's square x. Ito yung pinactor out natin na sine x. And the cosine n, that's cosine squared x dx. And we replace this part here by the identity 1 minus cosine squared x. So this will be 1 minus cosine squared x multiplied by sine x cosine squared x dx. So we multiply this sine x cosine squared x with 1, and that would be cosine squared x sine x dx minus this sine x cosine squared x by cosine squared x. It's integral of cosine to the fourth of x sine x dx. So from our topic 1, so from our first topic, we let this v is equal to the cosine x, and the derivative of that is, the derivative of cosine is negative sine x dx. So we would have the integral of cosine squared x sine x dx minus the integral of cosine to the fourth x sine x dx. So we have, since the derivative of cosine is negative sine x dx, so we have to multiply negative here and then negative sa labas. So the same dito, we multiply negative here and negative sa labas. Now, applying the general power formula, since derivative niya na to, then it's n plus 1 over n plus 1, so it's negative cosine n plus 1, so it's cube over 3, negative times negative, so that's positive, cosine raised to 4, so that's cosine n plus 1, it's 5 over 5 plus c, and this is our answer. So magdadagdag tayo ng example. Example 5.1.2. Okay, so if we remember dun sa rule natin sa type 1, either m or n is odd integer, no? Sa example 5.1, yung exponent ng cosine yung odd, and example 5.1.1, yung exponent naman ng sine yung odd. So what if parehong odd integer yung nandito? So meaning, magkakaroon tayo ng dalawang sagot. If we consider the sign, so we follow the rule dun sa katulad ng ginawa natin sa example 5.1.1. And if we choose the cosine, then we will follow yung procedure or yung rule na ginawa natin doon sa example 5.1. So dito, first, uunahin ko yung sine. So we factor out one sine, and that would be equal to the integral of sine squared x sine x cosine cube x dx. And i-express natin to in terms of cosine. So using the Pythagorean identity, sine squared x is equal to 1 minus cosine squared x. So that would be 1 minus cosine squared x multiplied by sine x and cosine cube x dx. So I would have the integral of this term times 1, it's cosine cube x sine x dx minus the integral of cosine cube times cosine squared, it's cosine to the fifth of x multiplied by sine x dx. Now, in order for us to apply the general power formula, we let our v is equal to cosine x, then your dv, taking the derivative, it's negative sine x dx. So makikita natin kulang tayo ng negative dito and kulang tayo ng negative doon. So we multiply negative cosine x cubed, it's sine x dx minus cosine to the 5th x sine x dx. So we multiply negative sa loob and negative sa labas, and we multiply negative here and negative dun sa loob. Now, itong negative sine x dx ay derivative na ng cosine, therefore we can now apply the general power formula. So it's just n plus 1 over n plus 1. So negative cosine, it's n plus 1, so cosine to the 4th of x over 4, and we have here positive n plus 1, so n is 5, that's cosine to the 6 x over 6 plus c, and this is our answer. Dito, it's the same example, no? So previously we choose the sign, so dito since pareho naman silang odd, yung pipiliin ko naman yung cosine. So I would have the integral of sine cube of x, si cosine bawasan natin ng a factor, si cosine factor out natin yung isa, and we have cosine squared x cosine x dx. We have here sine cube, and we express this in terms of sine using the Pythagorean identity. It's 1 minus sine squared x times cosine x dx. So we would have here sine cube times cosine x dx times 1, so it's sine cube x cosine x dx minus the integral of sine cube times sine squared, it's sine to the 5th of x cosine x dx. Now we let our v is equal to sine of x, and of course taking the derivative, your dv is equal to cosine x dx. So itong cosine x dx ay derivative ng sine, so we can now apply the general power formula. So we have here your n is equal to 3, n plus 1 over n plus 1, so that's sine raised to 4 x over 4 minus n plus 1 over n plus 1, so it's sine to the 6 x over 6 plus c, and this is our answer. Now comparing with the previous answer, whether ito yung sagot natin o ito yung sagot natin, parehong tama yun. So for type 2, we have the tangent x raised to n dx or cotangent x raised to n dx, where n is an integer. So to be precise, n is a positive integer. So we have to use the identity tangent square is equal to secant square x minus 1. Galing lang to dun sa may 1 plus tangent square x is equal to secant square x, and the cotangent square x is equal to cosecant square x minus 1, at galing lang to dun sa 1 plus cotangent square x is equal to cosecant square x. Now, for the first case, under the type 2, if your n is equal to 1, so for the tangent, if that is tangent x dx, that is equal to negative ln of cosine x plus c. At ito ay na-derive na natin sa previous example natin under sa topic ng integrals leading to logarithm. And of course, this is also equal to ln of secant x plus c. So sinabi ko doon na kapag yung apelyido ng isang tao ay tan, sigurado ang lahi niya ay insect. And pag apelyido niya naman ay cot, so that's insane. Pero joke lang yun. So if the integral is cotangent that is ln of sine x plus c. Now, what if your n is greater than 1? So, for the tangent, what we have to do is we express the tangent n of theta equal to tangent n minus 2 theta tangent square theta. So we factor out the tangent square and we express this tangent square into secant square x minus 1. So magkakaroon tayo ng tangent n minus 2 theta multiplied by secant square theta minus 1. How about in the cotangent? If we have the cotangent of the exponent n is greater than 1, so we express the cotangent n of theta into cotangent n minus 2 theta cotangent square theta. We factor out the cotangent square and we express this cotangent square into cosecant square x minus 1. So that would be cotangent n minus 2 theta multiplied by cosecant square theta minus 1. Example 5.2, we have the integral of the tangent x raised to 4 dx. So in this case, your n is equal to 4 and that's greater than 1. So we factor out the tangent square and we would have tangent n minus 2. So it's square x tangent square x dx. Tapos yung pinactor out natin na tangent square, i-express natin in terms of secant, and we would have tangent square x multiplied by secant square x minus 1 dx. And tangent square times secant square, so we have tangent square x secant square x dx minus the integral of tangent square x dx. Now, we let our v equal to tangent x and to check natin if this is the derivative. So your dv is equal to secant square x dx. So since the secant square x dx here is the derivative of tangent, we can now directly apply the general power formula. So n plus 1 over n plus 1, wherein your n is equal to 2. So we have tangent n plus 1, so that's cube x over 3. Then for this, we express this in terms of secant square. So express this in terms of secant square, and we would have negative integral of secant square x minus 1, so using the identity dx. And we have tangent cube x over 3 minus integral of secant square x dx plus the integral of dx. So the tangent cube x over 3 minus the integral of secant square is tangent plus the integral of dx is x plus c, and this is our answer. Okay, example 5.2.1, we have here the integral of cotangent to the 6x dx. So sabi sa rule, we have to express the cotangent n in terms of n minus 2 multiplied by cotangent square x dx. So we factor out the cotangent square. So we would have the integral of cotangent to the 4th of x cotangent square x dx. And we express this cotangent square x in terms of cosecant, and we would have cosecant square x minus 1 dx. So we distribute, and we would have cotangent to the 4th of x multiplied by cosecant square x dx minus the integral of cotangent to the 4th of dx. So we let our v is equal to cotangent. So if your v is equal to cotangent, then your dv is equal to negative cosecant x dx. So dito kulangan tayo ng negative, kaya magmo-multiply tayo ng negative siya. And we would have the integral of cotangent to the fourth x multiplied by cosecant square x dx. We multiply negative here and negative sa labas. For the second term, since this is n is equal to 4, so again, uulitin natin yung ginawa natin kanina. We factor out the cotangent square from cotangent to the fourth. And we would have the integral of n minus 2. So it's cotangent square x, cotangent square x dx. So for the first term, since derivative na to ng cotangent, so therefore n plus 1 over n plus 1, so it's negative cotangent raised to 5 over 5. Then for this, we express this cotangent in terms of cosecant. So we would have negative integral of cotangent square x multiplied by cosecant square x minus 1 dx. And this is negative cotangent to the fifth of x over 5 minus the integral of cotangent square x cosecant square x dx plus the integral of cotangent square x dx. So, imagine niyo kung yung exponent is higher than 6, medyo mahaba-haba talaga yung solution. Siguro mga to the 20th. Yung mga tipong pang final exam. Mga raised to 30. Joke lang. Okay. So, we have this is equal to negative cotangent to the fifth x over 5. And since pagbalikan natin ito yung kanina, hindi ko na isulat ulit ha. Let v is equal to cotangent x, then your dv is negative cosecant x dx. So, kulang tayo ng negative dito. Kaya we multiply negative sa labas and negative dun sa loob. So, we have here negative cotangent square x multiplied by cosecant square x dx. So, we multiply negative dun sa loob and negative dun sa labas. For the last term, we express this in terms of cosecant. So, that's the integral of cosecant square x minus 1 dx. So, this is cotangent to the fifth of x over 5 plus, since derivative na to ng cotangent, so therefore n plus 1 over n plus 1, so it's cotangent cube x over 3. Then, distribute natin to. So, we have the integral of cosecant square x dx minus the integral of dx. We would have negative cotangent to the fifth of x over 5 plus cotangent cube x over 3, and the integral of cosecant square x dx is negative cotangent, so minus cotangent x, and the integral of dx is x, so x plus c, and this is our answer. For the powers of trigo function type 3, we have the integral of tangent mx secant nx dx, or cotangent x raised to m and cosecant x raised to n, where n is a positive even integers. So, ibig sabihin, yung exponent ng secant or ng cosecant yung positive even integers. So, we would have here, sa tan sec muna tayo. So, we let the secant nx be equal to secant n minus 2x secant squared x. And then after this, we express this part here equal to tangent squared. So, gagamitin natin yung identity ng secant squared x is equal to tangent squared x plus 1. So, itong part na to ay papalitan natin ng tangent squared plus 1 to the power of n minus 2. So, this would be tangent squared x plus 1 raised to the power of n minus 2 secant squared x. And we will then obtain the products of the power of tangent and secant square. And we could integrate this using the general power formula. What if your n is a positive even integer para naman dito kay cosecant? So, we let the cosecant n x equal to cosecant n minus 2x cosecant squared x. And then, we will be using the identity cosecant squared x is equal to cotangent squared x plus 1. At itong part na to ay papalitan natin ng cosecant squared x plus 1. So, we would have cotangent squared x plus 1 raised to the power of n minus 2 cosecant squared x. And in here, we will obtain the products of the power of the cotangent and cosecant square. And of course, we can integrate this using our general power formula. If your m is an odd number, so dito kanina, we have our n is even. So dito naman, what if yung m natin is odd number? So ang gagawin natin, we express secant x raised to n tangent raised to m into secant n minus 1 tangent m minus 1 multiplied by secant x tangent x. So, ang mangyayari, itong tangent m minus 1 ay magiging even na siya kasi nag-minus 1 tayo. So, then we transform the tangent n minus 1x into powers of secant using the identity tangent squared theta is equal to secant squared theta minus 1. So, how about if m is odd and we have the form of cotangent x raised to m cosecant x raised to n. So, magkakaroon, i-express natin ito by extracting the cosecant cotangent. So, yung cosecant x raised to n cotangent x raised to m ay i-express natin in terms of cosecant n minus 1 of x cotangent m minus 1 of x cosecant x cotangent x. So, itong cosecant cotangent yung ini-extract natin dito. So, ang mangyayari dito sa cotangent x raised to m minus 1 ay magiging even na ngayon siya kasi nag-subtract tayo ng 1 dahil odd siya kanina. So, i-express natin yung cotangent m-1 into secant. That would be using the identity cotangent square is equal to cosecant square minus 1. So, ang mangyayari dito, lahat ng term natin ay magiging cosecant na multiplied by cosecant cotangent. Be careful kasi baka pag nag-multiply tayo dito, yung cosecant maipagsasama mo na naman siya doon. So, dapat itong cosecant cotangent naka-isolate talaga to siya. So, ito ay power ng cosecant. So, ang derivative ng cosecant ay negative cosecant cotangent. So, therefore, magagamit na natin yung power formula dito. The same dito sa kabila. So, since itong tangent na to ay ma-express na siya in terms of secant. So, secant times secant. So, kaya magiging secant na to, power of secant. And it will be multiplied with the derivative sectant. So, since derivative ng secant ay yung sectant, therefore, we can now use the general power formula. Example 5.3, we have the integral of tangent squared x secant to the fourth x dx. So, ang titingnan natin dito sa type 3 ng integration involving powers of trigonometric function ay yung exponent ng secant. So, sinasabi doon sa rule natin, if n is even, so ang gagawin natin, we will express the term secant n minus 2 of theta secant square theta. So, magkakaroon tayo ng tangent squared x, si secant, that's n minus 2. Since your n here is equal to 4, n minus 2, so that's square, secant square x, secant square x dx. Then we will express this secant square here to tangent. So we have here secant square x is equal to 1 plus tangent square x. So we would have the integral of tangent square x multiplied by si secant square, palitan natin ng 1 plus tangent square x secant square x dx. Then dpma, magkakaroon tayo ng integral of tangent square x secant square x dx plus, saan galing yun? It's tangent times 1 and secant square x dx times 1. So we have here tangent square times tangent square, that's integral of tangent to the fourth of x and multiplied by secant x squared dx. So times secant squared x dx. So next thing na gagawin natin is to let your tangent equal to v. So v is equal to tangent x. So taking the derivative, dv is equal to secant square x dx. So since derivative ng tangent is secant square x dx, therefore derivative niya na yung katabi niya, so we can now apply the general power formula. That's n plus 1 over n plus 1. So tangent n plus 1, so that's 3x over n plus 1, so that's 3 plus, here you have tangent n plus 1, so that's tangent to the fifth of x over 5 plus c. So what if we have higher exponent kaysa dun sa example, sa previous example natin? Even. So, sabi dun sa rule, ang gagawin natin, to express the secant n into secant n minus 2 theta, secant squared theta. So, we have tangent squared x. Itong si secant to the 6x ay, since our n here is equal to 6, so that would be n minus 2. So magkakaroon din ng secant to the 4th secant square x dx. So palagi ito yung second square yung in-extract natin. And etong secant to the 4th na to, that would be the secant n raised to n minus 2. So sinasabi kasi dun sa another step, nang gagawin natin is to express this secant n minus 2 of theta to tangent squared of theta plus 1 raised to n minus 2. So that would be integral of tangent squared x etong si secant to the 4th ay pwede nating sabihin na secant squared x raised to 2 times secant squared x dx. And this secant squared x ay i-express natin in terms of tangent squared plus 1. So we would have the integral of tangent squared x times tangent squared x plus 1 squared secant squared x dx. So, kung makikita natin dito, we have this tangent squared x plus 1. So, ang gagawin natin dyan ay i-expand natin itong term na to by binomial expansion. We would have tangent squared x. This is tangent to the 4th of x plus 2 tangent squared x plus 1 secant squared x dx. So, magkakaroon tayo ng integral of tangent to the 6x secant squared x dx plus 2 integral of tangent squared times tangent square, so that's tangent to the 4th x secant squared x dx plus the integral of tangent squared x secant squared x dx. So, since the derivative, the tangent is second square, if we are going to let our v equal to tangent x, therefore your dv is equal to secant squared x dx. So since ito ay derivative ng tangent, therefore we can now directly apply the general power formula. So we would have here tangent to the 7x over 7, so that's n plus 1 over n plus 1, plus 2 tangent 4 plus 1, so that's 5x over 5, plus tangent cube x over 3 plus c. And this is your answer. So in here, dito nagdagdag ako ng additional example. Example 5.3.1. So we have here the tangent of beta cube multiplied by secant beta cube d beta. So hindi sa lahat ng oras x yung ginagamit natin na variable. So it could be y, it could be any letter or any Greek letter, usually kapag ang function natin ay trigo function. So ano yung rule dito? Your m is an odd number because your m here is equal to 3. So if that is the case, ang sabi doon sa rule natin, we have to extract the sectant. So ang mangyayari ay yung tangent of m, theta, secant, and theta will be expressed into tangent m minus 1 theta, secant n minus 1 theta, secant theta, tangent theta. So, in-extract natin dito yung secant. And then, we express this tangent m minus 1 into secant using the identity tangent squared of theta is equal to secant squared theta minus 1. So, we would have tangent m minus 1. So, that's square beta secant n minus 1. So, that's secant square beta. Tapos yung in-extract natin, secant beta tangent beta d beta. So, si tangent ay i-express natin in terms of secant. And that would be secant squared beta minus 1 multiplied by secant square beta times secant. So, that's secant beta tangent beta d beta. So, etong secant square na to ay i-distribute natin dito. So, sabi ko nga, be careful. Baka itong secant beta ay maibalik natin dito. So, dapat itong secant beta, palaging kasama niya yung tangent. Kasi ito yung hinihiwalay natin, yung expression na secant. No? So, we have the integral of secant to the 4th beta multiplied by secant. So, that's secant beta tangent beta d beta minus, ito yon yung 1 multiplied by this expression. So, that's integral of secant square beta times secant. So, that's secant beta tangent beta d beta. Ano yung purpose nito? Ang purpose nito is this. We let v is equal to secant beta. Ito yun, no? So, your dv is secant. So, that's secant beta tangent beta d beta. So, since derivative nito ay nandito na, therefore, we can now apply the general power formula. So, we have here n plus 1 over n plus 1. So, that's secant 4 plus 1 is 5. So, that's secant to the 5th beta over 5. And this one, since derivative ng secant ay yung secant, so therefore n plus 1. So, that's minus secant cube beta over 3 plus c. And this is our answer. So, paano kapag nagsama sa isang case yung m, which is odd, and n, which is even? So, dito kasi sa type 3, magkaibang case to. Pag si m, we have to let the tangent m secant n into tangent m minus 1 secant n minus 1 secant. But if n is even, so we let the secant n equal to secant n minus 2 multiplied by secant square, no? So, either of the two, yung i-apply natin, parehong tama yung sagot natin. Magkaiba nga lang yung mukha ng sagot. Because, as you can see, if here in 5.3.1, your answer is secant, no? So if we go back to problem 5.3, since your n is even, your answer is tangent, no? Pero parehong tama yung sagot natin. So let's set an example for that. We have 5.3.2. So kasi dalawa yung case natin. Your n is equal to 4, so that's even. And your m is equal to 3, that's odd. We have rule for n, which is even, and m, which is odd. So, dalawa yung computation na gagawin ko. Uunahin muna natin itong case na to. So, we let our secant equal to, so we let the secant n equal to secant n minus 2 secant square of theta, no? And we express this secant n minus 2 into tangent, no? So we set that using this identity, secant square theta is equal to 1 plus tangent square theta. So I have here tangent cube psi. Sa second to the fourth, babawasan natin ang exponent na 2. So we have secant square psi, secant square psi d psi. And I have here integral of tangent cube, and si secant yung ito yung term na secant n minus 2. So that's secant ay magiging tangent. So 1 plus tangent square psi times this one, secant square psi d psi. So what if itong part na to, no, yung matira dyan halimbawa ay secant to the 6th of theta. So kunwari, ang gagawin natin dyan ay i-express natin siya always sa secant square. So 6 divide 2, it's raised to 3. So in this part here ay papalitan natin ng 1 plus tangent square. So that would be 1 plus tangent square theta raised to 3. So binomial expansion na lang to, no? So if this is to the 8, so that's 2 and 4 here, and that's binomial expansion to the 4th degree. Okay, so we have here the integral of tangent cube psi multiplied by secant square psi d psi plus the integral of tangent square times tangent cube, so that's tangent to the 5th psi multiplied by secant square psi d psi. And since paulit-ulit nating sinasabi that if we are going to let v is equal to tangent psi, so your dv is equal to secant square psi d psi. So since ito ay derivative ng tangent, so therefore we can now directly apply the general power formula. So we have here tangent to the 4th psi over 4 plus ito. So that's n plus 1 over n plus 1 tangent to the 6 of psi
over 6 plus c.
What if ito naman yung gagamitin natin? Pero the same problem ito, ha? No? So m is odd. So gagamitin natin yung isang rule. So yung gagamitin natin yung isang rule. Yung isang rule, sinasabi niya doon that we let the tangent m of theta secant n theta into tangent m minus 1 theta secant n minus 1 theta, and we express the tangent m minus 1 into secant. using the identity, tangent square theta is equal to secant square theta minus 1. Tangent cube ay babawasan natin ng isa. So, magiging tangent square psi, and si secant to the fourth minus 1 natin. So, that's secant cube psi, and yung in-extract natin, yung secant d psi. Okay. So, express natin si tangent in terms of secant, and we have here secant square minus 1 multiplied by secant cube psi, secant psi, tangent psi d psi. Now we distribute this secant cube secant dito kay secant square minus 1. So we have secant square times secant cube. We have secant to the fifth of psi multiplied by secant. So that's secant psi tangent psi d psi. Sabi ko nga, be careful sa pagmumultiply, baka itong secant na to ay maisama mo dito. Kasi nga sabi ko, dapat itong secant palaging magkasama, no? Kasi yung derivative ng secant ay secant para magamit na natin yung general power formula. Minus, for the second term, it's integral of secant cube psi, sec psi, tangent psi d psi. So if we let v is equal to secant psi, then your dv is equal to secant psi tangent psi d psi. So since itong derivative na to ay derivative nito, so we have the general power formula. So n plus 1 over n plus 1 lang, and we will have here secant to the 6 of psi over 6 minus n plus 1, so secant cube, that's secant to the fourth psi over 4 plus c, and this is our answer. So your answer could be